Algebra 2, Lesson 72, lines from experimental data and negative angles. So Lesson 72, or well, these experimental data problems are going to drive some of you mad. And the reason why is because there is no definite answer to any of these problems. We're simply estimating an answer. And your estimate should be fairly close to what the answer in the book is. The reason why there is no definite answer is because of the nature of the problem. So what these problems are doing is if an experiment was conducted and in the experiment we had 1, 2, 3, 4, 5, 6, 7. We ran this experiment 8 times. Each time we used different values of salt and carbon, and then these were the results. So if you ran the experiment with, like I think here's 7.5 grams of salt, your output would be looks like 95 grams of carbon. So we've got this experiment run 8 times, and we have to create what's called the best line of fit, or a prediction line as to what the experiment trend shows. So pretty much if we can come up with an equation to the trend of this experiment, well then we can guesstimate what would happen if we put 50 grams of salt, or if we worked higher on the scale. So that's what the goal of this problem is to find an average or an estimate for this experimental data, and we're going to express that in the equation of a line. Now, our typical equation of a line gets written like this: y equals mx plus b. However, on these experimental data problems, you will see we don't have an x-axis, we have what's called a carbon axis, or maybe it'll be fluoride, whatever. Our x-axis is actually related to an actual element, and same with the y-axis. So since y is salt and x is carbon, what we're going to be doing is instead of y, we're going to put S for salt, and instead of x, we're going to put a capital C for carbon. And that is going to be the basis of our experimental data line. So instead of y equals mx plus b, it'll be salt equals m times carbon plus b. So that's the first substitution that we're doing in this problem. And the hard part of this problem is picking a line of best fit. In the example, they're showing you the vast variations of lines that could be used. And neither one of these lines is wrong, even though they're both very different. And that's what's going to drive some of you mad, is the answer can vary. And some of you are going to have a lot of trouble doing this next step. It's very simple. Some of you will have no problem doing this next step. The next step is you look at the graph, and you can do this in pencil on your homework as long as you erase it out of your book. But in pencil, just guesstimate a line like that. That's the first step once you've got your equation down. I'm just going to guesstimate a line. That line is not wrong. Now, let's say I picked a different line. Let's say I'm looking at this and I think, what? I think it's going to go like that. That line is also correct. I can find the equation of that line. Or let's say I'm looking at it at this angle and I want it to kind of go like that. That line could also be correct. So none of these lines that I've drawn are incorrect. You pick one line, you draw that one line, then you find the equation of that line. I'm going to go ahead and use the example B as our problem here, and we'll compare our answer to the back of the book. And then another thing to note right here, written in the book, your answer will very rarely be the same. It says, however, your answer will almost never be exactly the same as the answers given in the back of the book. We're looking for approximately the same answer. So let's go ahead and do this in practice. On B, it tells us to estimate the location of the line indicated by the data points. Write the equation that gives hydrogen as a function of carbon. So they already give you the y equals mx plus b format in h equals mc plus b. So I'm going to go over to my work paper, and I'm going to write my equation as h equals slope times carbon plus b. And then I just have to find the equation of the line. So I'm going to guesstimate a line. Let's see here. Yeah, that seems good. So I've guesstimated a line right here. If you have a straight edge, use a straight edge. That'll help your slope a little bit better. And then I'm going to pick some average points off of this line. Again, they don't have to be exact. So here I can pick the point of, let's see, 101, comma 90, 101 being the x-axis, 90 being the y. So the first point I will pick is going to be 101, comma 90. So I've got one pair. The next point, I'm going to go ahead and try to go to the other extreme of my graph. The farther away I get from the line, the more accurate it'll be, the farther away my points are. And I'll use this one here. It looks like I've got 105 and 120. So my second point is going to be 105, comma 120. So now that I've got two x's and two y's, I can use slope formula to find out what m is equal to. So I will take y1, which is 90, minus y2, which is 120, over x1, which is 101, minus x2, which is 105. That will equal my slope. Up here in the numerator, I get negative 30. In the denominator, I get negative 4. The negatives cancel, so I get 30 over 4. Now, and when you're doing these problems, they actually prefer that you put your slope in, what am I saying, decimal form. Wow, that was a slow moment. So right now my m is equal to, that can reduce to 15 over 2. So my m is equal to 15 over 2, or 7.5. If I need to find a decimal estimate and I have a crazy fraction, I can go ahead and divide that in my calculator to get a good decimal. So right now my m is equal to 15 over 2, or 7.5. So what I'm going to do is I'm just going to plug this in to this equation with one of these points. I'll go ahead and use 105 and 120, and then I'm going to solve for b. So I'll go ahead and rewrite this equation. Instead of h, which is y, I'm going to put 120, because I'm plugging in this point right here. And then for slope, I'm going to go ahead and put 7.5. And then for c, I will put 105 for x. And that plus b. So now all I have to do is solve this equation for b. I'll take my calculator, and I'll take 7.5 times 105. I get, I'm still in scientific notation mode from our previous videos. I get 787.5. So this becomes 787.5. So then to finish solving this, I just have to subtract that value from each side of the equation. So I'll subtract 787.5. And that's going to equal b, as that cancels. So I'll go back to my calculator, and I'll type in 120 minus 787.5, and I get negative 667.5. So negative 667.5. So that is what b is equal to. So now that I have m and I have b, I can write the equation of my line. So the equation of the line, again, is not going to be x or y, it's going to be h and c. So h is going to equal 7.5, which is m, times c minus 667.5. That's my final answer. Now let's see how that compares to the answer in the back of the book. So the answer in the back of the book gives me that, where am I? And it is close enough. So, again, we just have to get close enough. If you have any issues with these or questions, let me know on Moodle. The other thing we're going over on this lesson, negative angles. Negative angles, pretty simple. All we have to do is just think about an angle from an opposite direction. So here we have the coordinate plane. We see that all of our angles start on origin and they go up, right? Now, negative angles, they start on a coordinate plane. So let's say we represent a positive angle. We'll do this in green. Right? And we have the positive angle of 45 degrees. What a negative angle does is it also starts at origin, Do this one in red. But instead of going up, it goes down, being negative. Now, we can represent this exact same 45-degree angle with a negative angle. Negative angles are also known as angles of depression. Now, what we see here is if this positive angle is 45 degrees, the negative angle starting from origin is going to be 315 degrees, because that brings it to an even 360. So this would be negative 315 degrees. So the nature of negative angles is they're kind of like the supplement, as it were, the complement to a 360-degree angle. Those aren't the proper terms, but they complete the circle. And so we could do another set of angles. Let's say we had orange and we did a 120-degree positive angle. The negative angle, we'll go in purple, that also creates that 120-degree angle, is going to come from the opposite direction. And if we subtract 120 from 360, we would get 240. So this is going to be negative 240 degrees. So the only difference between the negative angle and the positive angle is the direction that you move from origin or from the start point. So negative angles start going down, positive angles start going up. And then you can use two angles to represent the exact same angle. Now, where this matters is in regards to vectors. So I'm not going to do an entire rectangular coordinate problem here. But we'll go ahead and do the example here. They tell us to write 5 angle negative 230 degrees in rectangular coordinates. So I'm not going to go over all the steps of converting from polar to rectangle, but I will show you that first step of constructing the angle 5 to the negative 230 degrees. So 5 angle negative 230 degrees. We have our coordinate plane. And we're going to start from origin, and then we're going to go in the negative direction. And to get up to 230, we'll just count by 90 degrees. So this is negative 90, this is negative 180, this is going to be negative 270, so negative 230 is going to be somewhere in this second quadrant, and it's going to have a length of 5. Now, if this degree is negative, well, that looks bad. If that's negative 230 degrees, from this angle right here, our theta of the right triangle we would be constructing is going to be 180, well, 230 minus 180. So if we go 90, 180, the excess angle that we have here, or this theta, is just going to be 50 degrees. So once I have that degrees, I can go ahead and start solving with trig identities for the r and the negative u values of these rectangular coordinates. So negative angle is pretty simple. You just go in the opposite direction. If you need to brush up on converting from polar to rectangular, go ahead and watch back. Go ahead and back and watch the appropriate lessons. If you have any questions, let me know on Moodle.